Good afternoon, class. I wanted to take a little bit of time and walk you through the process of setting up the INotify property changed, because this is often pretty challenging for students to wrap their heads around. And I'm going to do that on the Aquarius ICE. Uh, and one of the things that I've hit in several points now is the idea that with inheritance, events in C# don't really behave the way we'd expect them to. So, for example, we'd like to be able to maybe declare our property notified down into the treat class here. That is defined in the system.component model class. So we have to pull that interface in from there. And then it is INotify property changed. And when we implement this interface, we are agreeing, not on the namespace, but on the class. So we're going to move that down here on the abstract class. We are saying that we are going to implement a particular event, which is public event. And then with event is really kind of a label that says this is going to be an event. Otherwise, we kind of declare it like a field. So it would be the name of the data type that represents, which is a property changed event handler, and then the actual event name, which is property changed, like that. And notice as soon as we did that, that red underline went down because we have now fulfilled the requirement of the interface. And like everything else, we need to make sure that we add a summary to this, and we'll say this notifies when a property of this class changes. Now, that's really all we would like to think we need in this base class. So if we jump to the Aquarius ICE, this now inherits that interface through the treat, so it is also an INotify property changed. We'll go ahead and say that explicitly as well. This used to be something we had to do at every level. I don't think we have to anymore, but it's still not a bad idea to really just reinforce the idea that we are using the INotify property changed here. Notice that this is not underlined in red because it inherits that event from the base class. And then we'd want to basically every time, for example, the size changes, notify that that size is changing. And we would do that, well, we can't do that like this because this is the auto property syntax. And it creates a getter and a setter and the spot to hold that in memory, but it doesn't allow us to do any additional functionality. So we actually have to tweak this. At this point, we're going to have to declare a private backing field for this. So we're going to declare our size, and we want that to start as small, so we can go ahead and put the default there. And then instead of using the auto property syntax, we have to expand these getters and setters. So we can either do the curly braces after the get, or we can use the lambda syntax and just say we're going to return size. So either like this, or we do a curly brace and a return size. And we want the lowercase with the underscore. Make sure that this is returning the private backing field, not your property. If this and this match here and here, then you're setting up an infinite recursion, which is definitely not what we want. So this is kind of the old way of doing it. These days, there's a lot of pressure on programmers to replace this approach with the syntactic sugar of the lambda expression, which just makes it faster to type. So you will see it represented both ways out there in the field. And we can do the same thing with the setter. The setter, we need some actual logic, so we definitely want to use the curly braces there. And we would want to say size equals value. So at this point, this property matches the exact same functionality we had before with the auto property. Now we can add the property changed notification triggering. Now the first thing we need to know is this property change can be null by default. So if there's nothing attached to it, it will have a null value. So this question mark checks to see if it's null. If it's null, it's not going to do anything after the question mark. And then we invoke that property, and we'd want to provide which property is being changed and how it's being changed. Now notice here that it's telling us that can't actually access this, and this is really because it's defined here in this base class. Now this is public, public right there, so it is a public event, but to actually be able to invoke, we have to be in the same class. And when I say same class, I mean the exact same class, not a derived class, because it doesn't work with inheritance the way we expect it to. So we can't actually call it directly like this. So we have to do something a little different, and what we do is we wrap or we create a helper method, and this is traditionally named OnPropertyChanged. So we'll go ahead and use that, and it takes as an argument a string, and this string is the name of the property that's changing. And we're going to invoke from in here rather than directly in the class. So here we can say property changed question mark period invoke, and now you notice it's not complaining anymore. The first argument is what object is sending this event, which should be this, because we're sending it from this treat class, and the second object, the instance of this treat class. And the second argument is going to be the property changed event args describing what property is changing. So new property changed event args, and we're going to provide the name of the property that's changing, which should be this property name up here. And that gives us a property changed event. Of course, we have to add our summary. Used to trigger a property changed event, and the name of the property that's changing. So that allows us to then call this not from the base class, but from the derived class. We could also call it from the base class if we need to change it there. And that also means that all we have to do is say on property changed. Oh, let me see. I did make this public. This should be protected. We don't want this to be called outside of the inheritance chain. So protected means that this class can call it and derived classes can call it, but no other outside code can call it. And we don't need to do this because that's handled in the base class. All we need to do is pass in the name. So we could pass in the string size and we're done. Now, one note, this string has to match this property exactly. And this is something that people often end up putting a typo in. So the real suggested property we use is, what we suggest instead is using the name of operator. So name of takes really a lot of different things, and it just returns the canonical name within Visual Studio. So in this case, we can pass in the size property. And notice that it's using the property name size there. It says this is the same symbol. We can also preface that with this.size, but it doesn't have to have the this.size, but that makes it a little clearer what we're doing. And what this name of does is it looks at this property and says, okay, what's the string representation that corresponds to this? And it will spell it exactly the same way, and it will return it as a string, which we're passing into property changed, which now means that we've got it doing exactly what we want. And we don't have to worry about if we misspelled something, because if we misspell this, maybe I do lowercase size, notice that we get a red underlining because we don't have a property named that. So we only can pass in properties and other things that have canonical names in C# here to make that work. So that's the basics of kind of setting up the INotify property changed. So you have to refactor all of these things to do that. So this Aquarius ice flavor would need to be changed the same. And basically in the setter, we're always going to notify that that property is changed. But what about something like this calories? We don't have a setter. So what causes the calories to change? Well, if we look at it, it's the flavor. Different flavors cause it to have different values. So when we rewrite this class or this property as with a private backing field, public Aquarius ice flavor underscore flavor equals, and then it's Aquarius ice flavor dot lemon is the default, and then here go ahead and turn that and add the setter. in our setter, we want to set flavor equal to value. And then on property changed, name of this dot flavor. Boom. Okay, so that would be just handling the flavor, but we know when this flavor changes, this dependent property calories also changes. So we would want to notify that that is changing here as well. And now we've handled what causes calories to change. Price is dependent on the size. So we'd come back up to the size and say on property changed, name of this dot price. And then name is dependent on both of them, size and flavor. So we would go back and add on property changed, name of this dot name. And then we can take that same code and add it down here. So we have to invoke the on property changed where that property is actually changing. So if it's a derived property, the change occurs somewhere else in our code, and we need to do it after that. Now, the other thing to keep in mind is these need to be triggered after the value changes. If we do them in the other order, we'll actually tell our UI what this on property changed is doing. It's telling our UI the property has now changed, you need to get the new value. So if we do this before we change the value, it will grab the old value, consider that to be the updated value, and then we'll update the value, and our UI will be behind. It won't actually match what our expectation is. So it's very important, change the value first, then do the notification. Now, the other thing you might keep in mind is that these notifications cause some processing in the GUI, and that can be a lot of work potentially. So if we're not actually changing the value, we might want to avoid doing that. And what do I mean? Well, I mean, for example, if we compare the current size to the value that's coming in, then we might want to just return without doing anything in this helper class to say, hey, the size that you're trying to set me to is my current size, so there's no reason to update everything because it's already at the right value. So we can either do that with a return. The other way you'll see this written is with a not equal, and then in that case we put all of this into the body of that if statement. So this helps us avoid unnecessary computation and calculation and processing when there isn't actually a change occurring, because the current size is the value we're trying to set it to. Now, this does have some implications. If you do this, it has implications for your tests, because your tests are often assuming that you are going to be changing. So if you're, for example, here we default to small. If our test sets this value to small, it's already small, this on property is not going to trigger. So if you write tests expecting it to trigger, be aware that that one test is going to fail because it's behaving as you've written the code, not as you've expected when you wrote your test. In that case, say you're using a theory and you're using the theory to set the size, then you could leave that one inline data out and write a second fact test to deal with changing the small, so you would reset it to something else. This is also one of the few places where using a conditional in a test is okay. You could, in your test, check to see if the size is small, and if it is, change it to something else, then go ahead and run your assertion after setting it to be the size that's passed in. So there are some tweaks you can do if you do want to use this. And this is recommended practice, by the way, because it avoids this extra computation if it doesn't need to be done. So in that case, you just need to update your test to reflect that. But that's really working with the on property changed. Well, actually, let's go ahead and take a look at the test too. So let's make a test to deal with this. So in our query size tests, we want to first of all make sure that we implement the INotifyPropertyChanged interface, public void fact, should implement INotifyPropertyChanged, and this would be a fact. So there's no argument or nothing coming in there. And what we would do in here is just assert that we have the INotifyPropertyChanged interface on the class, and the assertion to deal with that is assignable from. And this just basically asks the question, can this be treated as something else? So we want to treat it as an INotifyPropertyChanged. And I don't have my using statement in there, so it's going to complain that it doesn't know what that is. I'm just going to use the fully quantified name here. So system.componentModel.INotifyPropertyChanged. That should get it to stop complaining about that. Now it's complaining it doesn't have a ice variable. So var ice equal new Aquarius ice. And then we can just say ice. So this assertion is asking the question, can we treat this ice as a INotifyPropertyChanged? And if it can be, then it will pass. If it can't, it won't. So that's really just checks, do we implement the interface? But we also want to check that the interface actually triggers as we would expect. So we could, for example, do public void should notify of property changed, and then string property name, comma, and let's do a size. When size changes, size. So when we change the size, this should change. It's going to be a theory. We're going to use some inline data. Size dot start with large. So when we set this to large, we would expect, for example, the size property to change. And then add our theory in here. So we have var ice equals new Aquarius ice. Create our Aquarius ice, and we want to check that if we change this ice size, that's going to trigger that notify property changed. So how can we test that that's happening? There's actually an assertion specifically for that, which is property changed, and it takes as arguments first the object that implements INotifyPropertyChanged. Secondly, it takes the property name that should be changing. And thirdly, it takes an action, which is a kind of lambda syntax that's basically just something to run, a method to run that should cause that change to happen. And that would happen when we say ice.size equals the size that we passed in. And with this, we can say there's going to be 3 possible values, small, medium, and large. All right, so let's save all of these and let's run our test on that. So if we go to our test, run all tests, we'll discover our test for us. Test window here. And in our Aquarius ice test, notice we have should implement property change passes. Now in this fact, one of these fails. And notice the one that fails is size small. And that's because we have this little bit of optimization in the Aquarius ice, where if it's the current size, if we're setting it to the current size, we're not going to set it. Notice size equals small by default. So that's why that test is failing. That was the caution I gave you. So there's a couple different ways we can deal with that. Like I said, this is one of the few situations where I would say a little bit of logic in the constructor is not a problem. And that's basically if we check if size equals small. So if the incoming size is small, let's set our ice to be a different size. And it could be medium, whatever. It just makes sure that when we come down here and this action runs, the current size is not the size that we're trying to set it to. So this is a quick void not changing size when setting to the default size. Okay, And now if we go back and rerun that test, that change, it now passes. So that's kind of an example of how to do that. Now remember, we said that in the query size, not only is the size changing, but the price and name are also changing. So you'd want to go back to these tests and add, for example, when this changes, we'd also want inline data size.medium, or sorry, small. Oh, we'll keep with small again, small comma, and then we want to check that the price is changing. So you do all the dependent properties as well. So you can combine them in a single theory like this, or you can do them as separate facts. We didn't tell you had to do it one way or the other. We're giving you as much freedom as we can now. So we're going to relax kind of some of our expectations to make this allow you to really play with that. And notice that now this extra test is also passing, so we know that we've covered all those bases. So you want to make sure that you test all of your properties either independently using facts or all together using the strategies we've just talked about. And that's really all I have to go over today. Hopefully that will help you as you're trying to implement these INotify property change and really understand what those are trying to do.